Welcome to Lab 5, Choose Your Own Adventure. In this lab, we will be discussing two tennis balls, the first which bounces on a solid block, and the second which bounces on a tennis racket. The purpose of this lab is to discover how elastic the tennis racket is. Here in Tracker, although it is not necessary, I plotted every single point along the drop of the ball. This created these graphs for each ball, one on the solid book and one on the racket. We use this data to plug into our formulas. To do this, we will use the coefficient of restitution, E. Newton's law of restitution applies to the direct impact of two particles and the normal impact of a particle with a plane surface. The coefficient of restitution is basically a percentage of elasticity that, when multiplied by the velocity before impact, gives us the velocity after impact. Before collision, we can calculate the velocity of the tennis ball using final velocity equals initial velocity plus acceleration times time. Initial velocity in this case is 0 because it is dropped from rest out of our hand. Acceleration is negative 9.8 meters per second because of gravity, and the time is found from Tracker. We can use this formula to calculate the velocity right after collision with the racket. Using a bit of algebra, we substitute the values and find that the velocity after collision with the racket is about 4 meters per second. We can use the same formula in algebra to find the velocity right after collision with a solid. We find that that velocity is 3.47 meters per second, or about 82%. So the coefficient of restitution of the ball is equal to 0.82 or 82%, and the coefficient of restitution of the racket is 0.13 or 13%. When a tennis ball collides with any solid object, it will retain 82% of its velocity in the opposite direction, and the racket strings only retain 13%, for a total of 95% velocity. This is pretty efficient. Here's my model in Python. Here we set two graphs in each ball. The masses for the ball, which are obsolete, gravity, the initial positions, and the coefficients, and our main loop. When we run our module, we can see that it is very similar to the video we saw in Tracker. We can see here that the graphs produced by VPython are very similar to the graphs produced by Tracker. And this is how we know our calculations worked. Thank you for watching my lab.